Welcome to Brain Vision.
Mass is stretched further and released, then the mass will start to oscillate. Now it will take 1/4 of a period for the mass to move from the maximum displacement to the equilibrium position, and that's independent of the amplitude. So the time will be 1/4 of the time period, which is in terms of spring constant and mass. This will be 1/4 times 2 pi square root of m by k. But we don't know the spring constant k here. And to do so, we can use the first part of the information where we know the mass of the object. So we can find out the spring constant by the stretch distance corresponding to the weight suspended on the spring. So k will be equal to the external force, Ext, divided by the stretch, which is equal to mg over x. Now we know that m is 1.65 kg, g is 9.8 meter per second squared, and we can divide that by x, which is 0.215 meter. Combining this, we get the spring constant as 75.209 Newton per meter. So since we now know the spring constant, we can use this information on the first part to find out the time. So this will be pi by 2 square root of mass, which is 1.65 kg, and we divide that by the spring constant 75.209 Newton per meter. So combining this, we get the time as 0.233 second. All right, thanks for watching. I'll see you next time.